Look through the thermal optic of any modern anti-tank unit, and even the heaviest, most heavily armored main battle tank reveals its vulnerabilities. Whether navigating tight urban rubble or crossing an open desert, heavy armor is constantly hunted by advanced munitions. To destroy a 60-ton armored vehicle, an attacker needs immense, concentrated firepower. Historically, delivering that firepower downrange meant driving your own launch vehicle out into the open, putting your crew directly in the crosshairs of the enemy tank's main gun before you could pull the trigger. To solve this problem of exposure, modern militaries rely on the Self-Propelled Anti-Tank Guided Missile platform, or SPATGM. These vehicles are designed specifically to hunt and kill heavy armor on a highly fluid battlefield. If you want to understand the tactical engineering shaping today's conflicts, hit subscribe to Global WarWatch Network for definitive military tech analysis. Building a successful SPATGM requires a central engineering trade-off, prioritizing the physical speed of the missile versus prioritizing the stealth and survivability of the launch platform itself. You cannot maximize both at the same time. Today, we are evaluating 4 distinct systems that illustrate how different militaries approach this problem. We will look at specific platforms representing Russian, Israeli, and French combat doctrines. Mastering this specific trade-off dictates whether a modern military can project power and dominate the battle space, or if it will simply lose its expensive armored assets to a well-positioned enemy. We begin with the Israeli Spike NLOS. Rafael Advanced Defense Systems designed this missile around a single, uncompromising philosophy: total launch vehicle concealment to guarantee maximum crew survivability. This topographical diagram illustrates the concept of non-line-of-sight capability. By extending the operational range up to 32 kilometers for ground platforms, the launch crew can stay hidden behind a mountain ridge or deep within urban structures, completely out of the enemy's visual and engagement range. To hit a target it cannot see, the system utilizes a bidirectional fiber optic and radio data link. The missile streams a live video feed back to the operator, allowing them to manually adjust the target, change the flight path, or abort the mission while the missile is already mid-air. Looking at this rear-quarter image of the Spike NLOS vehicle launcher, you can clearly see the physical footprint required for this capability. It houses a heavy loadout of sealed canisters and a distinct sensor mast, creating a dedicated, specialized platform. The trade-off for this extreme standoff range and continuous operator control is speed. The Spike NLOS relies on subsonic flight, traveling at around 210 meters per second. This significantly increases the time it takes for the missile to reach the target. The Spike NLOS sacrifices immediate reaction time in exchange for unparalleled crew survivability. It takes the anti-tank guided missile out of the realm of frontline ambushes, turning it into a highly precise indirect artillery asset. On the opposite end of the spectrum is the Russian 9P1572 Khrizantema-S. This system completely rejects the standoff stealth philosophy, choosing instead to rely on brute force speed. This image shows a line of Khrizantema-S tank destroyers, identifiable by their pop-up dual launchers. Built on a modified BMP-3 chassis, these vehicles are dedicated heavy armor hunters. The 9M123 missile it fires reaches supersonic velocities up to 1,000 meters per second. This sheer kinetic speed drastically minimizes the target's reaction window, giving an enemy tank crew virtually no time to deploy smoke or activate defensive countermeasures. To ensure those high-speed missiles find their mark, the system uses a dual-mode guidance setup, combining millimeter-wave radar and laser beam righting. This allows a single Khrizantema-S vehicle to actively track and engage 2 separate targets at the exact same time. The tactical limitation here is exposure. Operating on a direct fire range of 6,000 meters, or up to 10 kilometers on upgraded variants, the launch platform must physically expose itself and maintain a continuous line of sight on the target until the missile impacts.
By requiring line of sight, the Khrizantema-S accepts launch platform vulnerability. It trades that safety for overwhelming kinetic speed and a tandem warhead that punches through 1,200 millimeters of armor, betting everything on killing the enemy before they have time to fire back. The Russian BMP-3M Dragoon tackles the anti-tank problem from a completely different angle. integrating missile capability directly into an infantry combat role. As seen in this photograph of the camouflaged chassis, the Dragoon is built as a frontline fighting vehicle. It is designed to operate directly alongside infantry troops, rather than acting as a rear echelon sniper. This cross-section diagram shows the vehicle's unique design input. Unlike platforms with external, dedicated launchers, the Dragoon fires the 9M117M1 Arkan guided missile directly out of its 100mm main gun tube. Firing through the main gun allows a single vehicle to engage heavy armor at 5.5 kilometers and then immediately switch to standard high explosive munitions to support an infantry assault against soft targets. The physical constraint of this system is the dimensions of the barrel itself. Firing through a 100mm tube limits the diameter of the missile's warhead, capping its maximum armor penetration at roughly 1,000 millimeters. The Dragoon gives up absolute anti-tank dominance in exchange for high tactical flexibility. It ensures that a single frontline vehicle can adapt to varying threats in real time, without having to wait for specialized tank destroyer backup to arrive on the battlefield. As you can see in this rendering of the highly mobile 6x6 wheeled chassis, the French EBRC Jaguar represents the modern middle path between raw speed and extreme standoff distance. The vehicle's heavy anti-tank payload relies on the 5th-generation Akeron MP missile, which is housed directly inside an automated pod on the turret. The Akeron MP utilizes an uncooled infrared seeker. By eliminating the need for heavy, pressurized gas cooling bottles, the system simplifies logistics and allows the crew to rapidly lock onto targets over and over again without depleting resources. This technology gives the operator the ability to select specific warhead effects right before impact. They can switch between anti-armor, or anti-infrastructure, or anti-personnel modes, allowing them to destroy a tank or breach a reinforced concrete bunker from up to 5,000 meters away. This jack-of-all-trades design comes with distinct compromises. It lacks the brute force supersonic speed of the Khrizantema, and it cannot reach the extreme 32-kilometer stealth ranges of the Spike NLOS. The Jaguar prioritizes expeditionary versatility. It trades extreme benchmarks in speed and range for a highly mobile, networked platform capable of neutralizing diverse, unpredictable threats on the fly. Pointing to a single specification sheet and declaring one system the absolute best is impossible in a vacuum. A weapon's effectiveness is determined entirely by how well its engineering aligns with a commander's specific military doctrine. This radar plot maps out the 3 competing doctrines driving modern armored warfare: speed, standoff, and versatility. For commanders who demand maximum crew survivability and the ability to strike unseen targets over ridgelines, the Israeli Spike NLOS is the definitive answer within the standoff doctrine. For forces focused on overwhelming an enemy with kinetic energy before countermeasures deploy, the Russian Khrizantema-S commands the speed doctrine. And for expeditionary forces that must deploy quickly and adapt to unpredictable threats without heavy reinforcements, the French EBRC Jaguar executes the versatility doctrine. Thank you for your time today. Please like, share, and subscribe to Global WarWatch Network. We'd also love to hear your thoughts in the comments section. Be sure to join us on social media. You'll find the links in the description. Ultimately, the most effective tank killer on the modern battlefield is not necessarily the one with the biggest warhead. It is the one whose engineering compromises perfectly match the harsh reality of the battlefield where it is deployed.